Welcome everyone at our meetup, where we have a go at answering the question, is DevSecOps really just having a dependency check in your pipeline? So today we'll talk about various problems that we've seen with tools implemented to improve security around the code we write and the code we inherit from dependencies. And of course, we'll offer some solutions that have worked for us. Before we jump into the content, I want to introduce all the speakers. So as we've mentioned, unfortunately, Katharina Dankert isn't with us today, but she still contributed lots in this presentation. And the second phase, that's me. I'm Jennifer Parak. I'm a senior software engineer at Thoughtworks. And my interest in security started actually during university, where I studied advanced computer science. But then when I joined the real world of software development, before Thoughtworks, I was not very much involved in security. So I would be part of a development team, and security was usually done by some DevOps teams. I guess it was only when I joined Thoughtworks, I learned about a left shift security approach and got much more involved, actively involved in security as a security champion and being part of the security guild. So that's about me. Maybe Tim, do you want to introduce yourself?
So I'm Tim Fletcher. I'm an infrastructure consultant here in Thoughtworks Berlin. I first got interested in security when I used to work for a big school in the UK, and I had to do data forensics on children's mobile phones to recover what the children had been recording videos of, which led me to learn more and more about sort of defensive security and sort of data forensics. I've studied data forensics at the Open University, and now I do infrastructure security and defensive security for Thoughtworks and for the teams I'm part of. And Teresa.
Yeah, hi, I'm Teresa. I am a developer at Thoughtworks, and I first got interested in security when I was working for my previous company, and I built a shopping cart that was annoyingly secure. Then security has become a real passion of mine. I got into doing some pen testing, and now I am working towards my OSCP certificate. Next slide, please, Tim.
Okay, great, thank you. As for the agenda of today, we'll jump into the motivation, talk about why security is important and why we wanted to do this meetup. And we also conducted a small survey on problems that we and other teams at Thoughtworks have seen around security measures implemented. So we'll talk about the usual problems that we've seen. And finally, we, as I said, will offer some solutions that worked for us and how we tackled some of these challenges. I think we mentioned before, we'll pause for Q&A after the problems statement and also after the solution section. So stay tuned for that. And I'll hand over to Teresa to talk about the motivation.
Great, thank you. So we put the presentation together because one, we're all really passionate about security and we care about keeping our software secure. Two, we also really enjoy sharing the experiences and challenges that we face and thus lessons learned. And three, ultimately, because the internet is a hostile place. Next slide, please, Tim. So as you can see from this graph, this is a graph of the world's biggest data breaches and hacks up until April 2021. And security incidents are happening all the time, irrelevant of the size or complexity of your organization. So this really drills the point home that it's not a question of if, but when someone tries to hack our companies. And what is a common root cause for these hacks? Next slide, please, Tim. So here you can see the OWASP top 10. Now, OWASP stands for Open Web Application Security Project. It's a not-for-profit organization that aims to improve the security of software. OWASP researches and compiles the OWASP top 10, which is an awareness document that aims to give a broad consensus of the most critical vulnerabilities to web applications. And here are their 2021 results. And as you can see in the bottom left, vulnerable and outdated components is up there. So when a security bug is found in software, it could belong to any category of these vulnerabilities. And once the fix is made, this security bug is made public. This means that both good and bad developers can learn about this vulnerability. Malicious threat actors thus have an advantage if you're not keeping your software up to date. There are even tools to automate exploitation of certain vulnerabilities, such as Metasploit, which has an eternal blue exploitation for the Microsoft OS. So keeping your dependencies up to date and keeping in step with the latest responsible disclosures and associated fixes is one of the most effective ways of mitigating cybersecurity risk. It's not just going to help you protect against injection attacks, but all of these top 10 vulnerabilities in one way or another. Yet, as indicated by the massive wave of data breaches and ransomware attacks, all too often organizations are compromised over missing patches and dependencies. So how can you effectively incorporate this practice into your software delivery lifecycle?
If you go on the next slide, something that you hear quite often in the context of security, especially at Thoughtworks, is the need to shift left on security. So in the next few slides, I'll briefly explain what we mean with shifting to the left. So on the next slide, like at this slide, you see a path to production. And we usually start on the left with requirements analysis. Then the work gets split up into user stories, which are usually implemented by the developers. And then finally, the software makes it into production on the right. And what we've seen with clients sometimes is that security is only done at the end when the software is ready for production. So actually shifting to the left means that we want to put security at the beginning, or at least from an order from left to right, to make sure we have feedback on our secure software as early as possible. So as is common with Agile software development, it's all about a quick feedback loop. So this is what shifting left really helps us with. So let's talk about how we can implement this. On the next slide, we see a framework that some of our colleagues have developed. This is the secure path to production and includes various stages. So our goal is really to build security into each of these stages. And in our previous meetup, we extensively talked about how we could implement security into the design phase. Namely, what we want to do is do some risk management upfront, and we want to be aware of our assets and security objectives by usually conducting also regular Agile threat modeling workshops. So if you're interested in this topic, we'll share the slides later on. We'll have a link to the recording. What's most important to know that during the design phase, it's all about knowing what's actually important in your system. And then you're trying to manage the risk from there. And in the next slide, we'll see the scope of our current meetup. So we want to focus on the phases of code and inherit. So during the code phase, you want to ask yourself, for example, how can we support our developers to write secure software? An obvious measure is maybe you want to introduce a static code and a linter that scans for code smells. So hereby you would be supporting your developers with tooling. However, you could also focus on regular knowledge transfer. And as for the phase of inherit, in this kind of phase, you want to usually ask yourself, how well do we know the code that we rely on in our dependencies? So for example, do we have tooling in place that warns us about certain vulnerabilities in our dependencies? So let's take a closer look at these two stages and the challenges that we've actually come across. Next slide, please.
But instead of just talking theoretically about different dependency management tools, we wanted to do something a little different. We've surveyed our colleagues across the Thoughtworks ecosystem to find the common challenges that they face with the code and inherit parts of the secure path to production. We're going to now present the top three sort of categories of common problems with 3 example scenarios and the commonalities that the example scenarios share. And just to point out, this is not a critique of the tools that are being used. These are purely just examples.
So let's start with the first example. So imagine there's this team. The team in question, they wanted to implement a tool to keep their application dependencies up to date. And the solution they come up with, they implemented a tool called dependabots. And dependabot, what it does, it scans for your like all the dependencies in your application and sends you a pull request to update to the latest version. So this is the situation, and there was multiple problems that the team faced. First of all, they felt a bit overwhelmed by the amount of pull requests they received. So there was a bit of lack of communication, how to react to any of these pull requests. It also sparked a discussion on whether to auto-merge, so to merge the pull requests automatically, or whether to code review each one of these pull requests. So the question was really, are we confident enough in our dependencies to merge to the latest version? Or do we have to code review each PR one by one? And another problem that they've come across was the discussion around whether to pause any feature delivery, like any user story that we're working on. So they found themselves in a situation where they had to compromise. Do we want to update always to the latest version, or do we want to speed up on a feature delivery? So this was the first scenario where the team was faced with problems when they were trying to keep their app dependencies up to date. And now let's look at the second scenario.
So the second scenario is keeping your system dependencies up to date. So the scenario is that a team inherits an unfamiliar and complicated infrastructure based on Terraform and an old version of Terraform, let's say version 0.10. Even though there are no direct threats to the infrastructure, no CVEs or security discussions on any forums, the team knows that it's best practice and most agile to update their version of Terraform. So there are a few challenging questions that the team has to answer before they can do this. Do they update Terraform in small increments, or do they do it all in one, or do they find a compromise? And then when they decided the increment step, do they go straight to the bleeding edge version of Terraform, or do they choose something that's more stable? Once again, another compromise. Also, how can the team be confident that something hasn't broken? Is it just when the production server goes down? Let's hope not. Also, how could the team then make this continual care of the infrastructure code, infrastructure versions, a common ritual? Without having these answers, what it caused the team was the anxiety of actually starting to update the Terraform version. It also meant that there were feature delivery prioritized over actually updating the version, which essentially means that this problem just gets worse and worse and worse. And so the final scenario is that the team has transitive vulnerable dependencies. So the team wanted to keep on top of all of the vulnerabilities in the dependencies, and so they add npm audit to their pre-commit hook. They wanted to flag up these vulnerable dependencies, but what npm audit actually does is, or did, was flag up vulnerable transitive dependencies really deep down in the chain of dependencies. And these vulnerabilities don't necessarily have fixes. So once again, there were some difficult questions that the team needed to answer. What would be the impact of either upgrading or downgrading a dependency so the issue would be fixed, or doing nothing if it wasn't possible? What would be the impact on the code? How could they be certain that by either upgrading, downgrading, or doing nothing, that things weren't going to break? If they had decided to do nothing, how do they flag these false positives? And how do they communicate the reasons why these were chosen as false positives later on? And so what I hope you have spotted throughout these three scenarios, if we can see the next slide, please, Tim, is that there are some commonalities shared. We've affectionately called them the 5 Cs. That's compromise, context, communication, confidence, and continuous. So there are many situations where teams would have to come up with a compromise. So for example, in scenario 1, it would be, do we code review each pull request, or do we set up an auto merge, or something in between the two? For scenario 2, it was the decisions between, do we update Terraform little often, or do we make this huge jump? Whether to go to a bleeding edge version or not. Context. Now, context could be in the sense, for example, in scenario 3, like how do we understand the impact of upgrading, downgrading, or doing nothing to a dependency? But also context in the sense which we saw in scenario 1 and 2 of how do we communicate the necessity of good dependency management to the business when we have so many variables that we're not sure about, which then nicely leads us to communication. How do you communicate to the business the importance of good dependency management? I think a good point, an interesting example also of why communication is an important challenge in shifting left is also in scenario 3, where there was the communication topic around how to communicate the decision to developers in the future, to a developer that onboarded later on. For example, another point that is common across all these 3 scenarios is confidence. How can teams make these changes and be confident that the dependencies that they're updating are not going to break things? And finally, continuous. How do these teams, once they've decided how they're going to handle lots of these scanners screaming, how can they turn this into a ritual? And so these are all challenges that your teams will face when trying to shift left with security. But they are challenges and themes that your team will need to make decisions on, because the alternative is pretty scary.
Now for the real world. You've probably heard of the Equifax data breach. This was caused by a piece of software called Apache Struts, which is part of how you build Java-based applications, front-end, back-end web services, widely used in sort of enterprise IT, big banks, governments, large internet companies. Lots of companies use it. And in March 2017, a vulnerability was discovered in Apache Struts that had an enormous impact. We basically gave you access to all the data that flowed through a website without any restrictions. You could access databases with this vulnerability. But Equifax didn't patch this. They didn't actually roll out the update. So March 2017, this became known, and it was very widely published at the time. That CERT, the US government's emergency response team, was communicated about it. It was in the sort of mainstream news press. This wasn't just in the tech industry. But Equifax actually didn't patch this until May, and then in May there was unauthorized access to files containing customer data for 148 million people. That's 148 million people who had their addresses leaked, had their dates of birth, their names, their credit history, their social security IDs, all of the information necessary to sort of conduct fraudulent transactions, to find these people in the real world, to actually steal real money from them. And Equifax only found out about this at the end of July 2017 through their security team monitoring and finding suspicious network traffic. It wasn't because they patched the hole, it was because they saw suspicious traffic. And this is an example of how, because you aren't deploying continuously, you aren't rolling out small updates. It's much harder to do that huge step that is needed when you realize that you've got this vulnerability, you've got this across hundreds of applications that you need to rebuild. If you're not doing this automatically and continuously, it just looks like such a huge hill to climb that people stop doing it. And also, you need to understand your context. You need to know where this application is in use. Where is Apache Struts? Where is it? Is it in all parts of our website, or is it only in a few places? And how do we deal with that? How do we communicate about what's happened to those people? How do we make sure that those people are actually well treated? How do we say, look, we've lost your data, but we're going to make it, we're actually going to support you to make things better. And that didn't happen as well. And Equifax are discovering that so far, this has cost them $1.7 billion. That's in legal fees, that's in settlement claims, that's in restitution to customers, that's also in the sort of investment in actually fixing these problems. And the final reason that the sort of rollout didn't happen is because it's really hard to test this stuff, because how do you know once you've updated this framework that things actually work? How do you do this automatically? How do you have confidence in your application working after you've rolled out a patch? So you can see that what looks like fairly small pieces of work around patch management and understanding updates, rolling things out continuously, can have an enormous real world impact. And now we'll have a little break for any questions. If people have any questions, put them in the chat, and I'll put them to the panel.
Now that we've terrified you all.
Doesn't look to be any questions, so shall we move on?
Let's move on.
Yeah, we're not just going to leave you with the relentless worry of a cybersecurity threat hanging over you. We're going to now discuss some strategies we've used to address some of these challenges and topics of conversation that we've just brought up. So the first one, what's at stake? How do you communicate to the business what's at stake? How do you put the threat of cyber security into the context for an organization to properly understand the risks? In a world where cybersecurity threats seem ever more present, you think it would be simple to get organizations to prioritize making their software secure. But unfortunately, it's rarely so straightforward. Businesses don't necessarily disagree that security is important, but they focus on delivery. So how do you shift the focus and demonstrate to various stakeholders what's at stake if they don't take security seriously? Well, a tool that we use is by building an asset library. An asset library is a catalog of all the valuable items of your system. And building an asset library allows business and developers to have a common understanding of a common language of risk and a common understanding of the harm an asset could have to the organization if it were to be exploited. So if we go to the next slide, we can see a quick example of an asset library. So this is one built for the OWASP juice shop. It's a fake e-commerce website selling juices, but really it's a playground for basic cybersecurity skills. I'm not going to talk in detail about how to build one of these. We have other literature that you can look at for that. But essentially the gist is that you have your assets on the left, and then you have the CIA triad as columns, and that's confidentiality, integrity, and availability. And inside each field is a disaster scenario. So what would happen if? And you also have color coding for the impact this would have on the organization if this disaster scenario were to unfold. So let's look at credit card information, for example. If the credit card details of the people buying juices from the juice shop were to be compromised, then they would be no longer confidential, and this would lead to legal issues. The integrity of the service would be affected as the customer's cards could be used fraudulently. And finally, as customers cancel credit cards, they would not be able to buy the delicious juices.
And then once we have our asset library ready, we can pick up another tool in our toolbox, namely the Agile Threat Modeling Workshop. Again, we did a whole meetup on this topic, and we'll share the recording in our references. But I want to actually briefly focus on why this helps us. So the outcome of an Agile Threat Modeling Workshop is a set of prioritized action items, and they focus on the specific scope that you're currently working on to make the software more secure. And so what I've seen in regular Agile Threat Modeling sessions, really the center of the workshop is putting the security into the business context. So we always go back to the asset library and we make sure that we only focus on security, like fixing security threats that are really important for our current scope. And then usually what I do is I make sure that the whole team is attending the workshop, because what happens during the workshop is that there's a clear communication between everyone. I mean, business analysts, QA, developers, tech lead, and we all talk about the security topics and their prioritization. Another C that we touch from us 5 Cs is the compromise that happens also during the workshop. So the amount of times I've heard people complain about having an hour meeting with everyone attending, I totally understand it. But what I found is that usually it's an investment to make sure that the whole team is involved with the security topics that are relevant at the moment. And then finally, another thing that I really like, another valuable thing it brings is the continuous conversation about security. So usually we do this threat modeling little and often. That means with every user story or epic, we do the threat modeling and talk about security. I think the best thing that can happen is that everyone gets involved in this. So whenever our QA tests our software, they think about security. Whenever the BA writes a story, they think about security. So that's what this tool really helps us with. And then let's talk about our next experience in the next slide. In some of the scenarios, we've seen a question come up. This was, okay, we have lots of tools implemented, and now what? So essentially, there's the need for team rituals to ensure that the team can handle any situation well. And the real winner was really the question of to block or not to block the pipeline. So at some point, when you decide to implement a vulnerability scanner and in your pipeline, you need to decide what to do. For example, in scenario 1, the team, the team decided to not merge any pull requests automatically. So they maybe would go for a approach where they block the pipeline when there's a vulnerability. I've seen other kind of tricks I received from a colleague. They actually only fail the pipeline when they've reached a certain number of vulnerabilities in the dependencies, and then they fail the pipeline. And that means at this point, someone stops their current user story or whatever they're working on, and they go ahead and do the update. So I think, again, you see there's a compromise that we need to do, but we need to decide it and communicate it and then execute it. So this is about the conversation whether to block or not to block the pipeline. And the second point, like the problem that we found also in the survey and people have communicated is the classic red fatigue. So that means that maybe like if you're a developer and you receive an email every time your pipeline fails, at some point you'll start ignoring it because that's normal. It's completely natural. It happens to me also. Because sometimes you didn't do a commit, you get this email, you say, okay, someone else will worry about it. And again, this is normal, but it can get a bit dangerous. And the advice here, or the solution here would be only alert if it's tied to an action. So when I get an email, because, I don't know, the build failed or whether there's a vulnerability detected, I only want to get it if there's actually an action that I can do as a developer. And this will hopefully solve the problem of red fatigue. Another thing one of the really important things I want to mention when we talk about team rituals is that I said already, decide, communicate, execute them, but give the team room to change them. So usually if you're in a Agile software development team, you might have retros. This is a great space to reflect on the rituals that you've set yourself and maybe try something new if you have to. But the main point here is continuously talk about it and be brave enough to change something. So this is everything I want to say about team rituals. And now I'll hand over to Teresa to talk about education of the team members.
Great, thank you. So you don't need 20 years of cybersecurity experience to have confidence that you know what you're doing, but You do need to have a solid basic understanding, and you do also need to know your tools. So pick a tool set and learn how to use it. A thing that we've also found is that it's really also important to document why you chose the tool set that you've chosen. Document why and the decision parameters that you use to make that decision. Why should you do this? Because it's often a problem that somebody new will come in and say, oh, hey, this is a great tool, but have you seen tool X? If you make it transparent what's important, then you already have a very clear sort of criteria of what your tool needs to do, and it makes it easier to rationalize why you actually chose tool Y instead of this tool X that this new person has brought in. It's also, documentation is an art form though, so you're not going to get it right first time. Something that we have used is lightweight decision records. They're really useful. Also invest in building capacities across the whole team. And the team should really be able to do the basic stuff. So for example, maybe try a disaster recovery with your team. We've had experience with Thoughtworks where a team tried to do it for the first time, and it was supposed to take them 2 hours, but it in fact took them 2 days. And yes, that sounds terrible, but the team were very, very glad that they practiced it, because if the time were to come where they needed to do this under pressure, then at least it would be the first time that they were doing it. And finally, sharing knowledge across the organization. This can be through tech huddles or brown bags. These are really good opportunities, not only to focus learning and make sure you have some content for a presentation, but a really good way to spread knowledge and open up a forum for discussion around security. Also, what has helped is lots of weekly catch-ups, security guilds, having a security champion in the team. This really, I cannot stress it enough, this helps build confidence in the teams that they actually know what they're doing around security, and yeah, naturally communication. And the final slide that we're going to talk about is team accountability and awareness. As we've already mentioned above, create a community around security, talk very openly about failures, blameless postmortems, things like this. Exchanging and fostering cross-team collaboration to improve security awareness. Accountability, have cross-functional teams that all have some knowledge about security topics, don't have it siloed into one person, and ensuring that as you're trying to build this security-focused community in your organizations, that you get some feedback to the team, making sure that it is actually having the impact that you think it will. Great. Next slide, please. Are there any questions?
We have a question from Lars. Where should a team start? Are there any public resources you can recommend for how you start in a team which is new to this? We all have answers to that.
Yeah, let's all contribute. I might start. I think it's a really, really good question, because I've asked myself that a couple of times. Been in the situation where you start a new team and you don't know what to do. What I've done in the past times is that I started off really with a risk management and a security objectives workshop, where I actually would sit down with our product owner and the tech lead, or at least like a small number of groups, to look at the system that we're trying to build, and first kind of outline the assets, and then also define the security objectives that we're aiming for. And then I think Teresa already mentioned this, the outcome there will be the asset library, and I think this is a great start to kick off any team to talk about security.
Thank you. Interesting answer. Actually, what I was thinking about was more of this if you have a team without much security knowledge. So not having security consultancy from outside.
I think then the same rules sort of apply. What I would also suggest is then, I mean, you don't need to have an external security expert to help build some of the basic knowledge. We've got some references at the end of the presentation for the previous presentations that we've given around Agile threat modeling and also the asset library building. It doesn't take an expert to bring these best practices in. Certainly not. It just takes a little bit of commitment.
Yeah, I think I really want to stress that because Teresa, you're totally right. Again, like in my past experience, I do not come from the classical security engineer background, and I still kicked off those workshops because I think what we're aiming for with the left shift security approach is that we're making sure that we're covering the low-hanging fruits. And I think developers usually have a good sense of that. And then you can always try and get professional help later on. But this is about making sure what you have and what you know is already covering the basics, I would say. And any security expert, like I've seen in the past, they're like really happy that you've done the groundwork because then they can actually help you a lot better.
And also, I think none of the sort of speakers here tonight have had any formal security training. All of us are self-taught in some way. In some way, we picked security up because it's interesting and because it was something we cared about and wanted to learn more about. I did that 15 years ago, and it's just that I have more grey hair, so I've done more security stuff. What I would say is start asking questions to understand what are the drivers for your organization. Why do they have to care about security? And who are you worried about from security? Are you trying to secure your systems against fairly basic attacks on the public internet, or are you trying to worry about something a bit more in depth? And then you can start to think about how you can prioritize that, how you can think about it. Because as people have said, the agile threat modeling, it sounds intimidating. It really isn't. It's looking at your systems, it's breaking them down. It's almost working. It's working in a similar way to your QAs, your quality analysts, or your developers would work, thinking what in my system needs to be better. But rather than thinking about features, you're thinking about security. As people have said, Jennifer and Katerina gave a presentation about how to do agile threat modeling. That we'll link to as well. So it was recorded. You can watch that. There are a lot of resources about how to do agile threat modeling, but I think the short answer is ask questions and start asking questions and start thinking about how you can what's your first step? What's my first question? Where do I start? How can I make one little thing better? So we have another question. Sorry, Lars, does that give you enough to go on to start with? I'll take that as a yes.
Yes, sorry, unmuting took time. Thank you very much for the answer.
Great.
So we have another question of if you build new secure versions, but you have many environments, for example, lots of Kubernetes clusters, how do you make sure all your environments have been updated, particularly if the sort of environments are not fully controlled by the team delivering those updates?
Tim, do you want to take this one?
That is so. The question there is really that's a governance question. So that's a question. So there are tools you can get for sort of Kubernetes to monitor the state of your Kubernetes, to look at container versions, to do container scanning. But really, it's about either figuring out how so if you're building the new secure images to roll out, you would then look at sort of Have you got tooling in your Kubernetes cluster, things like admission controllers? If you've got continuous scanning for your container versions in your clusters, what is the impact of the environments not being updated? Who cares? What is your governance process around that? Because you've got two problems to solve there. First of all, understanding that your clusters are out of date. And secondly, actually who's going to care about that? Who's going to remediate that? So you have two separate problems to solve. The first one is there's good Kubernetes tooling around versions and image controllers that can sort of plug into Kubernetes. The second one is very much a business process and a conversation to figure out how you're going to actually do that within your particular organization, what the consequences are for those clusters being out of date, and who's going to update them.
Okay, Marcel says thanks in the chat, so I believe we answered the question.
Yes, organizational governance is very challenging. That is what the project I've just rejoined is. We're trying to figure that part out. Katerina has also given an excellent talk in InfraWebConf a few months ago about how you do Agile security in conjunction with big corporate security. So I think there's a reference to that in our references slide.
Yeah, I've put that one in.
Cool. So we have reference slides here. So those are also gives you something to follow up on. Any other questions?
Perhaps more of a, what is your opinion about maturity models? So like OWASP DSIM, security belts, BSIM, what else? OWASP SAM.
Mm-hmm.
Do they help or not?
Teresa, Jennifer, are those tools you use in either of your projects?
I've never touched them, so.
No, I actually have never used them.
So one of our projects I know a little bit about that does use that. They are one of the tools, and again, it's back to the building the confidence of your team, giving the teams tools to work with. They are another tool in the sort of arsenal of helping distributed delivery teams understand where they're up to in security terms. We were looking here particularly about dependency managers, but the sort of tools and maturity models you're looking about, and that is, it's just part of it's another conversation to talk within the team about how you are building that maturity, how you're building your confidence to do security well. And as with any tool, they can be effective or they can not be effective depending on your context. So there's a very consultancy answer there of it depends.
Okay, thanks.
We've got two more questions. One from Marcel around supply chain vulnerabilities with dependency updates.
Gladly, I don't have experience with these vulnerabilities yet. I believe we wanted to actually talk about one example concerning that previously. But then again, I think the one scenario that we talked about, I think this is one of the reasons why the team, or I think now I can say that I was part of this team of scenario one. And I think this was why we chose never to auto-merge anything we got from the dependabot, just because we wanted to verify every pull request. At least it was definitely also a request from the business just to cover such a vulnerability for sure. So everything that came in, we had to code review, at least one person had to code review, which again brings us back to this compromise. So there was this decision, yeah, feature delivery is important, but whenever there's an update, first stop what you're doing, first review it, and only then yeah, merge it to master. This is what we usually do. I hope that answers Marcel's question.
And also on that, there are some of our clients have sort of take a layered approach to this, that they only apply dependency updates through systems that they manage. So they do patch mirroring. which they then do security scanning of the mirrored patches. It buys you a bit more time and a bit more visibility of your supply chain potential supply chain attacks. It's also a question of, and again, as Jennifer said, it's about the context. It's understanding, is your system critically vulnerable to a particular patch? How do you judge that? A particular update, how do you judge that? Is it something you need to merge straight away, or is it something which you can wait on? And also, the supply chain attacks are difficult to mitigate because you have also ones that can just provide newer versions of normal dependencies. So it's not just about auto patching; it's also about updating dependencies in general. And how you pull dependencies in. So there's a lot of there's a lot of challenges there, and it's also how you build layered defenses around your supply chain. So the question from Frank is about deciding not to update dependencies. How would you? So is it something you really can decide not to do?
I think there are points. Maybe if you've got dev dependencies and there's no way that they're ever going to make it out to the internet, then yeah, then you don't necessarily need to treat them with the same kind of scrutiny as production dependencies. And also potentially there is, if you've got transitive dependencies, it's affecting a part of the code base that you don't actually use. So there are options, but yes, you're right. We should be on the more updating side of things and not updating.
I can actually recommend some reading. I think that answers this question really well. I've read a while ago a book called Sandworm by Andy Greenberg. I can totally recommend it because this is about kind of the recent hacks and kind of like the history of it. And when you read it, you see this pattern where people publish vulnerabilities, and big corporations like Microsoft, they decide not to patch for a while, and then it becomes a major breach.
And there is a very consultancy answer with it depends, and it comes to your understanding your context of your code. As Teresa said, is the vulnerability in code paths that are actually in use in your application? You have to understand your application. If you feel you don't want to patch for whatever reason, then you need to invest to understand the why and how your dependency impacts your application. Where is your dependency used? Is it just something you build with and then you discard? Or is it something which is integral to your application and which you're going to have to update because of how the vulnerability is sort of works? And generally speaking, you should update, but sometimes updates have impacts. And there's the usual example of Microsoft's Patch Tuesday. Not everybody patches on Patch Tuesday. A lot of enterprise organizations wait until the next Tuesday. Let people test first. And that is a trade-off. That is a compromise. The enterprise organization is accepting that they will be at risk for a little bit longer in the interest of not disrupting their workforce's productivity. Just a compromise.
I hope you're all hearing the 5 C's time and time again. Sorry.
They're all everywhere.
They're everywhere.
Max is asking a question: is driving security a bottom-up responsibility to the devs or a top-down responsibility of top-level management who are probably ultimately accountable?
Great question. Who'd like to go first? I can. I think it would be great, but if it was a top-level management down approach, but it really is. So we have the slide talking about how to, what's at stake, and that's really getting at this issue. Like, how do you explain to top-level management what is at stake when you don't take cybersecurity seriously, when you don't take dependency management seriously? Because it seems from the outside trivial, but what I hope we have illustrated in this talk is that it's not. It's very, very important and really the backbone to good cybersecurity best practices.
And I think a thing that I would add to that, so as a developer, after this talk, probably like I'm super scared of all the things that can happen, especially that like with the left shift approach, I'm now responsible. And what really helps me the most is actually if the team shares this accountability. I think Teresa talked about this in her slide. Like if we now share this responsibility together, it's much less scary, right? So this is something that I would also always push for, to make sure that this is distributed not just to one person, but across the team.
And I think the answer is it's both as well. That the leadership of organizations sets the context to say that security is important, and that they empower teams to actually care about security as well as feature delivery. It's also a responsibility of delivery teams to understand what the organization's security postures is. Is this organization at risk from a particular group of people, a particular threat actors, and how that feeds into your development practices, how you think about security. And if the organization says security is important, then it comes to the development teams to say, this work here, we can't deliver these features at the same pace as we have in the past, because we need to care about these things around security. So there's very much a sort of there's a communication channel which has to exist between the leadership of an organization and the teams that deliver the functionality and the features for that organization. Any more questions? We've had some really good questions so far. Does anybody have any more? Otherwise, I will move to our closing slide. Oh. And Frank is just, yep, that's exactly right, Frank. I'll move to who's doing our closing quote?
I can.
Thank you, Jennifer.
I can do that. So this is a quote that came up from a survey, and I'm just going to read it out because I like it a lot. So there's a lot of focus on scanners and tools, and a lot of it is vendor-backed. But in reality, people are the most important to deliver secure software, and their training in using tools should be a first-class aspect of integrating technologies. So I want to close our meetup with that. And I thank you so much also for all the valuable questions at the end. Really enjoyed this part the most. And yeah, hope to meet you all again, some meetup.